So now I'm going to look at the discount approaches. And I said the discount approaches are the approaches or the methods that consider time value of money. Do you get it? So time value of money just simply means that time can change the value of money. Meaning that 10 cedis today will not be the same if you leave it for 10 years. 10 years time, you won't be able to, buy some things in terms of purchasing power. So that's what it means. So you realize that the ones you did previously, the payback period and the accounting rate of return, those ones, they didn't consider time value of money. Because that one, they were giving us the cash flows for every year. So assuming maybe year one, you're getting 10,000 cedis, year two, 20,000 cedis, year three, 30,000 cedis. The ones you're getting in the other years are future values, not present values. So it means their purchasing power right now is not the same. That 20,000 cedis that are getting in year two is different from 20,000 cedis right now. That 30,000 cedis you might get in year 5 or year 6 is different from 30,000 cedis right now. You get it? So the net present value just tells you how much you are going to get from an investment right now. If you want to see, like, assuming like you are able to get the money right now, how much is it going to be? You get it? So it's not going to tell you how much you are going to get at the end of this particular year. It will tell you how much you are going to get right now. I hope you get it. So let's take a question on it and see how we are going to tackle it. So we have the year. So it's quite similar to the payback period, but this one, we are going to change all the future values to the present value. Do you get it? So that's the difference. So year two, we are going to change it to the present value. So as if, let's say, someone give us the money now. If year two, imagine someone gives you like 30,000 cedis. Someone tells you that they want to give you 30,000 cedis in, let's say, 2028, or maybe next 2 years, or next 3 years, or next 4 years. And you want to know how much that money will be worth now. It's the same thing as this one. So you want to see how much all those investments will be worth now. So you're going to change all the future values to present values. So let's take the question. So we have year, then 0, 1, 2, 3, 4. Then we have investment A. So this is one particular investment. Then you have 100. Then year 1, we have 20. Year 2, we have 60. In year 3, we have 20 again. Then year 4, we have 50. Then year B, we have 200, which is for year 0. We have 40, 100, and 20, and 800. So the question says, assuming cost of capital is 20%, advice based on the net present value, which of these projects should be accepted? So the cost of capital is 30% in the question. So let me write it somewhere here. Costs of capital is equal to 20%. So which of the projects should be accepted? So the cost of capital is 20%. And I'm going to use that one to find the internal rate of return. So I'll explain what the internal rate of return means later on, but for now, let's focus on the net present value. But the internal rate of return just basically is where the NPV is equal to 0. So it's more like where you are breaking even. Do you get it? So if we calculate for the net present value and we get a positive value for the net present value, it means it's a good investment. You should go about it. But if you get a negative, meaning that you shouldn't undertake that investment. Do you get it? Okay, so now let's find the net present values for all this one. So I'm going to change all the values to present values so that we know how much you're actually going to get. So if the net present value is positive, meaning that we should go about the project or we should continue with the project. But if it is negative, yeah, it means we shouldn't go about the project or we should not undertake the project. That's what it means. So let's start with investment A. So we're going to solve for investment A. So for investment A, let me do it. So yeah, we have year, then 0, 1, 2, 3, 4. Then we have the cash flows. So this is investment A. So we have the cash flows. So we have 100. In year 1, we have 20. Year 2, we have 60. Year 3, we have 20. Year 4, we have 50. And I said when we were doing the payback approach that for this one, if you see year 0, it means how much you have invested. This 100 cedis is not what you've got. It means you've invested 100 cedis. You get it? So year 1, we have 20. Year 2, we have 60. Year 3, we have 20. And year 4, we have 50. So these values are the future values, what we are going to get. But we want to change all to the present value so that we'll see what we are getting right now for the investment to see if the investment is actually good or not. So the first thing I'm going to find is the discount factor. you need to find the discount factor before you can change the future values here to the present value. You get it? So that when we multiply the discount factor by the cash flows, you are going to get the present values. You get it? So when I do it, you understand. So the discount factor, we are going to use DF. You get it? And the discount factor, we are going to use 20%. Since the question said the cost of capital is 20%, so let me do it into brackets 20%. So the discount factor is just 1 plus, let me put it here. So the discount factor is 1 plus R exponent negative n. If you want to find the discount factor for any investment, 1 plus R exponent negative n. So this one, R, which is the cost of capital, is 20%. You get it? So the 20%, you are going to change it to decimals. You know, anytime you are doing investment appraisal or business finance, you always change the rates to decimals. So 20%. So when you do 20 over 100, you are going to get 0.2. So going to 1 plus 0.2, then exponent the number of years in negative. You get it? So for year 0, the discount factor is obviously going to be 1. Because if we do, let's say, 1 plus 0.2, which is the rate, exponent negative 0. The 0 is the number of years, the 0, we are going to get 1 because every number exponent 0 or negative 0 is 1. So for year 0, we don't calculate it. So every time once you see year 0, then you just put a 1 there. So the discount factor is 1 because it's already in the present value, so you don't need to change it. So for year 1, the discount factor is going to be into bracket 1 plus the rate. The rate is 0.2 exponent negative 1, the year, negative n, so negative 1. And when you put it on the calculator, what do we get? So we have 0.833. So 0.833. Then for the second year, we have 1 plus 0.2 exponent negative 2 because it's the second year, so it's negative 2, and to be equal to 0.6944. 0.694. So let me just do 0.694. Then the third year, we have 0.578. 0.578. The third year into bracket 1 plus 0.2 is the negative 2 is equal to 0.578. And the fourth year, so 1 plus 0.2 is therefore negative 4. So when you see the year, just put negative and the exponent. 1 plus 0.2 exponent negative 4. I'm getting 0.482. 0.482. You get it? So these are the discount factors for all the years. So for us to get the present value, we are going to multiply the discount factor by the cash flow to get the present values of the future values. So when we do that, so since we've already calculated, okay, let me just add it. So you can call that the present values or the discounted cash flows. Present values or the discounted cash flows. In some books, you see present values. Some books, you also see discounted cash flows. It's the same thing. So the discounted cash flows is the cash flows times the discount factor. That will give the discounted cash flows. So for the present value, so for year 0, it's going to be negative 100. It's supposed to be 100 times 1, but this 100 is going to be negative because you're going to subtract. So, and another thing I want to mention is that anytime you are doing investment appraisal and you see a number in brackets, it's always negative. So if you see a cash flow or you are calculating for profit or anything, and you see negative 20 or you see into brackets 20, it means negative 20. So this one, we put it in bracket because it's going to be negative 100. You get it? So for the present values, the investment or how much you invest, which is 100 cedis, is always going to be negative. You get it? We are calculating for the discounted cash flow. So for year 0, it's going to be negative 100, but the rest are going to, you are going to leave it how it is. So year 1 is going to be 20 times 0.83. So 20 times 0.83. We're getting 16.6. 16.6. Meaning that in year 1, we're actually going to get 20 cedis. So we invested 100 cedis. In year 1, we're going to get 20 cedis. But right now, the value is actually 16.6. So 16 cedis, 60%. That's what it means. It means at that time, you might get your 20 cedis. But right now, assuming you want to know the present value of that 20 cedis, it will be 16 cedis, 60% or 16.6. Then year 2, you are going to get 60 times 0.694. You are getting 41.64. 41.64. So it also means that in year two, we're getting 60 cedis in year two. So if someone gives us the money at that time or in year two in the future, but right now the value of the 60 cedis is 41.64. So meaning that in year two, we are getting 60 cedis. But when you change it to present value right now, you're getting 41 cedis, 64% or 41.64. Then year three is going to be 20 times 0.578. 20 times 0.578. We are getting 11.56. 11.56. That is 11.56. So year three, we're getting 20 cedis. That's in the third year. But right now, if you want to know the value to be 11.56, then year four as well is going to be 50 times 0.482. We have 24.1. So as the years are going, you see that the money keeps on reducing. So these are the present values. You want to see the worth of the investments right now, or how much you're going to get from the investments like right now, today. If someone tells you that like, what is the worth of the investment, or how much are you going to get from the investment, and you want to know the worth now, you add all the present values. Do you get it? So let's add the present values. So it's going to be the first one, which is negative 100 plus 16.6 plus 41.64 plus 11.56 plus 24.1. And we are getting negative 6.1. So our net present value is equal to negative 6.1. And like I said, if your net present value is a negative number, then it means you should discard the investment. Don't go ahead and do it. You get it? But if it's positive, it means you can go ahead. So if we solve for B and we get a positive, it means you should choose investment B over investment A. That's what it means. And for the present values, to some of the books, you see that here they don't write anything. And they'll add all these ones, then minus the costs. It's the same thing. So all this minus the 100 is the same thing. So I just mean here negative 100. So I just add everything to get a net present value. So since I get negative 6.1, it means you should discard it. So let me write it somewhere here. So NPV of A is equal to negative 6.1. Then the rate was 20%. Rate was 20%. So you guys understand why I'm writing it. So that's for investment A. So now let's go to investment B. I shouldn't have cleaned the number of years. Okay, use this. So for investment B, we're just going to do the same thing. So it's going to be the year 0, 1, 2, 3, 4. Then the cash flows, which is 200. So the values of the investment be 240. Then year 2, we have 100. Then year 3, 20. Then year 4, 800. So these are the cash flows, how much you are going to get. But we want to know how much it will be worth now. So the same thing, we find the discount factor, which is the same as DF, the discount factor. You get it? And we are going to use the same rate, the 20% we use. So as I said, this is the formula for the discount factor, 1 plus R exponent negative N. So for 0, anytime you see 0, the discount factor is always 1. So you don't need to calculate it, it's 1. So for this one, the discount factor is going to be 1 plus 0.2. So they are going to be the same for the ones we did. So here is 1 plus 0.2 exponent negative 2. Because the second, then 1 plus 0.2 is a negative 3 because it's the third year. And 1 plus 0.2 exponent negative 4 because it's the fourth year. So exponent the year that you are in at that time. So we've already solved for them. So let's check the values. So year 1, the discount factor was 0.83. Year 2, it was 0.69. 0.69. I think 68 something, but 2 decimal places, 0.69. So here was 0.57. Then the last one, 0.48. So I mean, when you multiply this by this, then you get the present value, how much you are going to get right now, which is the same as the discounted cash flow. So discounted cash flow or the present value. So here, like I said, it's negative 200. That's the cost because you're going to subtract it. Right now, you've already invested it, so you're not getting it again. So that's why it's negative 200. Then 40 times, so CF times DF will give you the DCF. So 40 times 0.83. You need to give 33.2. Meaning that in year one, we got 40 cedis, but the present value as of now is 33.2. Then year two, 100 times the 0.69, which is the discount factor. You are getting 69. And year three, we have 20. Then year three, we have 20 times 0.57. So 20 times 0.57. You are getting 11.4. Meaning that the 20 cedis that is here right now, the value is 11.4. Then year 4, we have 800 times 0.48, 0.48. Then that's giving us 384. Meaning that the 800 that we are going to get in the fourth year, right now, the value is 384 cedis. That's what it means. So now we're going to add all the DCS or the discounted cash flows to get our NPV. So the NPV, you just add all of this. So when you add it, getting negative 200 plus 33.2 plus 69 plus 11.4 plus 384. You're getting 297.6. This is the net present value for B. So now our net present value for B is 297.6. So let me write somewhere here. Net present value for B is equal to 297.6. And the rate is also 20%. And since our net present value for B is positive, we can go ahead and undertake it. So we are going to say, so in case the question asks you between A and B, which project should you go for? You're going to say project B, simply because the net present value is positive. Therefore, you can go ahead and undertake it because it's like a good investment. But if it's negative, then you discard it. That's what it means. So now we're done with the net present value. We are going to go to the internal rate of return. We are going to use the same values for the internal rate of return. So let me clean it and explain to you how the internal rate of return works. So now I'm going to move on to the internal rate of return, and I'll use the net present value to explain it. So the internal rate of return, in simple words, is more like when your NPV is equal to 0. It's more like when you are breaking even. Do you get it? So the company will give you their standard. So if yours is more than the company's own, it means you are making more profits as compared to the cost. So they'll give you their standard so that you don't go below it. It means that if you go below it, your cost is more than your profits. That's why they give you the standard. The formula for the internal rate of return is A. So I'll explain what everything means. So A plus then a fraction. Then we have NPV of A over NPV of A minus NPV of B times into brackets B minus A. So this is the formula for the IRR, which is also called the linear interpolation formula. So A plus a fraction with a numerator NPV of A over NPV of A minus the NPV of B times the B minus A. So now I'm going to explain the formula, but before we go into the formula, I want you to understand the concept of the internal rate of return. So this part is a bit tricky, but then try and understand it. So for the internal rate of return, before you get it, let's say for investment A only, if you want to get the internal rate of return for investment A only, you are supposed to get two values for the net present value. You have to get one net present value that will be positive and one net present value that will be negative. And to get a net present value, I'm going to go through the processes that I went through, everything I got. Now pay attention very well. When we were finding the NPV, the company gave us the cost of capital as 20%. You get it? And when we saw that for 20%, the NPV of A, we got negative 6.1. And then NPV of B, we got 297.6. Now, please try and pay attention. If you get an NPV, a negative NPV, or an NPV that is negative, for example, the NPV of A, we got a negative number, you need to choose a lower rate so that you get another NPV which will be positive. To find the IRR, we'll need two NPVs. Do you get it? we need NPV A and NPV B. This is just for one. So assume you are calculating for investment A or any investment. This is just the formula for one investment. So for that one investment, we need two NPVs. We need an NPV that will be positive and an NPV that will be negative. And I'm saying that when you solve for the first one, they'll give you the cost of capital. So this one, they give you the cost of capital. If you get a negative NPV, you have to take a lower rate to get another NPV which will be positive. You get it? If you also get, assuming you also get, let's say, a positive. So for this one like this, when you use the same 20%, you got a positive, you take a higher rate so that you get a negative NPV. It's a bit confusing, so you somehow you have to chill it. So I'd like you guys to write this down. So for the formula, the A is equal to the A here is the rate that gives you a positive NPV. A rate that gives the positive NPV. That's the A. The A you see here, that's the rate that gives you the positive NPV. Then B, the B you see here is the rate that gives you a negative NPV. And NPV A is obviously the positive NPV. Then NPV B is the negative NPV. And this is just for one investment. So the A will always be smaller than the B. I want you to know that. And the NPV A will always be positive. The NPV will be negative. So here will become positive, negative, negative. You get it? So this is just for one investment. You get it? So right now, we are going to calculate the IRR for investment A. Please pay attention. We are going to calculate the IRR for investment A. And for investment A, we solved for the first one. So when we solved, we got negative 6.1, meaning that don't let the letters confuse you. This is NPV for investment A, not the A here. So let me just change the values to X and Y so you don't get confused. Let me change here to X and here to Y. You get it? So NPV of X, NPV of Y, so that you don't get confused. So now for investment X, our NPV was negative 6.1 when you use the 20%. So now let's trace it here. So we said that the rate that gives you a negative NPV is B. The rate that gives you a negative NPV. So meaning that the 20% gave us the negative NPV. So meaning that our B is 20%. The rate that gives you the negative NPV. And straight away our NPV of B is the negative 6.1. I hope you guys get it. We are saying that the B is the rate that gives you the negative NPV. And this 20% give us a negative NPV here. So straight away for the investment X, our B will be 20% because that's the rate that gave us the negative 6.1. And our NPV B will be and our NPV B, which is a negative NPV, is negative 6.1. The NPV that's negative 6.1. And now we have the NPV that is negative, but we also need the NPV that is positive as well. You get it? We need the NPV A. We only have NPV B right now. You get it? So let me just write it. So right now, our NPV B for investment X, NPV B, which is the negative NPV, is the negative 6.1. Then our B is the rate that gave us the 6.1 is 20%. So now we have the BB, but we don't have the NPV for A and the A. Now, since we have a negative NPV, we also have to get a positive NPV. And to get that, you have to choose a rate that is less than the 20%. When you do that, you're going to get a positive NPV. So any rate that's less than 20%, it's best to take around 10. Usually they use 10 and 20. So let's take the rate for 10%. You are going to find the present values again using 10%. Do you get it? So now let me just write the values here. So the NPV B is negative 6.1. Then the B is 20%. So now we already have our NPV B. So now we need the our NPV, that will be A for the X. So we are going to do for the X, then you guys do for the Y. So the same thing we did with the 20%. This time our cost of capital is 10%. So let me do it here so that you guys can see 0, 1, 2, 3, 4. I hope you guys can see. Then the year. So we have. Let me write the NPVA here. So NPVA is equal to the positive NPV. Then NPVB is equal to the negative NPV. So that I can clean this one. So the table can go higher a little. So now we are going to do for 10%. So yeah, and 0, 1, 2, 3, 4. Then we have the cash flows. Then this is how much you invested. So we put it in brackets. And you have 20, 60, 20, 50. So we're going to do what we did for the 20% now, the same thing. So our discount factor, which is into brackets. So now we are going to use 10%, which is the discount factor is the 1 plus R exponent negative N. You get it. So let's find, and I said the first one, the discount factor is always 1. So now 1 plus negative, so now it will be 1 plus, since our rate is now 10%, 0.1. Because 10 over 100, 0.1, exponent negative 1, because the year is 1, and the N is the year, so negative 1. So 1 plus 0.1. So 1 plus 0.1 exponent negative 1. I'm getting 0.9. So 0.9. 0.9. Then 2 is 1 plus 0.1 exponent negative 2. And we have 0.82. So 1 plus 0.1 exponent negative 2, because you're in the second year. So you have 0.82. And year 3, 1 plus 0.1 exponent negative 3, have 0.75. So 1 plus 0.1 and negative 3 is equal to 0.75. And year 4 will be 1 plus 0.1 is the negative 4, because year 4. And we are getting 1 plus 0.1 is a negative 0.68. So now we found the discount factor. The next thing we are going to find is the discounted cash flow. The discounted cash flow. The discounted cash flow is the CF times the DF, the cash flow times the discount factor. And that's going to give us the current value or the present values for the future values. So how much you're actually going to get every year. So like I said, for year 0 is always negative 100. So negative the cash flow. So it's going to be 20 times 0.9. So 20 times 0.9 is equal to 18. So year 1, we're actually getting 20, but the present value now is 18. Then year 2, we have 60 times 0.82. We have 49.2. So yes, we have 49.2. So we're actually getting 60, but the present value is 49.2. And now we have 20 times 0.75. 20 times 0.75, which is 15. So the present value is 15. Then we have 50 times, which is 50 times 0.68, 0.68, 34. So now to get our net present value, so we are still in investment X. So we want to get our net present value. So the net present value will be, so we'll add all the discounted cash flows. So you have negative 100 plus 18 plus 49.2, and plus the 15 plus 34 points. Sorry, plus 34, yeah. We are getting 16.2. 16.2. 16.2. So now we got 16.2 for the same investment X. 16.2 when we use the rate of 10%. This time we use the rate of 10%. This time we use the rate of 10%. So what that means is that when we use the 20%, we got a negative. But when we use the lesser one, which is the 10%, we got a positive, which is 16.2. And what did I say? I said the rate that gives you a positive number is A. So now we can say A. So let me clean this one. So A is the rate that gives you the positive number. So that is the 10%. Because the 10% is the rate that gives us the positive number. And straight away, our NPV of A, which is the positive NPV. Positive NPV is 16.2. You get it? So now that we have all the values, we're going to substitute it in the formula. So let's clean all this and substitute it in the formula. So now substituting into the formula, we said A is the rate that gives you the positive number, so which is 10%, because 10% gives us a positive NPV. So we have 10 plus the NPV of A, which is 16.2, which is our positive NPV, then over NPV of A again, which is 16.2, minus the NPV of B, which is the negative NPV. So it's going to be minus into bracket, another minus again because it's minus 6.1. Then times B minus A. B is 20, A is 10. So 20 minus 10, which are the rates? So let's do it on the calculator and see what you get. So we have 10 plus 16.2 over 16.2 minus into bracket negative 6.1 times into bracket 20 minus 10. So you are getting 17.26. 17.26%. So our IRR is now 17.26%. So the question, they'll always give you their minimum IRR or their expected rate of return. So if in the question they give you 15% and the 17.26%, then means you can go ahead with the project. But if it's below, so if you solve for investment Y, and let's say so this is for investment X, let's say investment Y, you got maybe 18%. Since 18% is higher than this, then investment Y should be accepted. That's what it means. So you guys should do the values of investment Y. Let me know what you get. So that's about it for investment appraisal. We've done the accounting rate of return, the payback period, the internal rate of return, and the net present value as well. So please go over it. And if you don't understand anything, please let me know in the comment section. And I'll see you in the next video. Bye.